Question 3. A student uses this apparatus to investigate how the angle of a ramp affects the time taken for a toy car to travel down the ramp. You've got a diagram here, clearly showing angle of ramp and toy car, with points A and B labelled. This is the student's method. Set the angle of the ramps 10 degrees and measure the time for the car to travel from A to B. Repeat the experiment for 5 different angles using the same car travelling from A to B. The table lists some variables in this investigation. Please place 1 tick in each row to show the independent, dependent and control variables. Now then, the definition of each one of these is the independent variable is the thing that you changed. The dependent variable is the thing that you measure. And the control variable is the thing that you keep the same. In this experiment, we are using the same toy car each time. So we pop a tick in there. The time taken to travel from A to B, that's what we're measuring. So that is the dependent variable. The angle of the ramp is the thing that we change each time. So that's the independent variable. And the distance traveled down the ramp, that must be kept the same. That's the A to B mark. So that is another control variable. The second part of the question shows the student's results. And then it says, draw a table for the student's results. Now then, there's no repeated readings for each angle. Just one reading of time for each angle. They are in a mixed up order, however. So what you need to show is a table with 2 columns. And you need to have angle here. And you need to make sure that you put the unit. And here we have time. And again, you must make sure that you put the unit. That's seconds. The angles have got to go up in consecutive order. So we've got 10, 20, 30, 40, 50, 60. And then your times for each one. Notice that we do not put units into this bit of the table because we've already got them in the heading. Oh, and there isn't a 60. I got carried away there. Okay. The next part of the question involves a graph. So, question C. The graph shows the results of the student's investigation. Circle the anomalous point on the graph. An anomalous point is a point that does not fit the pattern of the other data. And it's quite clear that that one is just there. Suggest how the student should deal with the anomalous result. So, first of all, they would ignore it and not include it in any line of best fit or further data analysis. And then they would repeat that 30-degree angle in order to get a result that maybe fits in with the pattern a bit more. The next part of the question says draw the curve of best fit on the graph. And to do that, you have a little look at the points and you think, will it be a straight line or will it be a curve? This will be a curve. So you freehand draw a curve like so. Suggest why the student did not start the axis from 0. This is to do with the amount of graph paper that he is using. Okay, so making a better use of the grid means that he's basically not got any wasted space on his graph area. So if he starts at 0.4 here, he's only got 0.1 kind of space at the bottom where there's no points other than the anomalous point. Whereas if he started from 0, he would have a whole lot of empty space down here. And it doesn't really do any, there's no use with the graph. So you can say any of the following things. You could say it makes better use of the grid. Or you could start saying things like, if the angle were at 0, then that car would actually not be going anywhere. The resultant forces on it would be 0. It would be at rest. And that's that for question 3.